Today, we define the most important part of trigonometry, and that is the 6 basic trigonometric functions. They are going to be based on a right triangle. So let's start by looking at this right triangle right here. As you can see, this right triangle, we have highlighted this bottom um, angle and called it theta. That is the Greek letter theta. If you look at a right triangle, what do we call this side of the triangle that is opposite of the 90-degree angle? Do we remember? That is called the hypotenuse. So both of the angles that we could be interested in, this guy and this guy, they are always going to be next to the hypotenuse. When we look at theta here, the side that is touching the angle theta but is not the hypotenuse, so in this case the side A, because angle theta is made of these two sides and the second side is not the hypotenuse, this side is what we call the adjacent side. Adjacent means next to. So this is the side that is next to the angle theta we're interested in that is not the hypotenuse. Then if we look at the third side, notice how this third side is not touching this angle theta. It is not one of the two sides that makes up our angle theta, but it is directly opposite of that angle theta. So for our angle theta, we would say that this is the opposite side for the angle theta. So every triangle, if we look at one of the two acute angles, is made up of a hypotenuse, an adjacent side, and an opposite side. Those three sides can then be put together to create our 6 trigonometric functions. So let's define those 6 trigonometric functions now. The long way to write these are sine, cosine, and tangent. Those are our 3 main trigonometric functions: sine, cosine, and tangent. So, what is the sine of an angle? Well, the sine of theta is just what you do is you take the length of the opposite side and divide it by the length of the hypotenuse from the angle theta. So, in our example up here, that would be the opposite side has length b, and the hypotenuse has length c. So we would just do number b divided by number c, and we're done. That is sine. Cosine is similar. Cosine is similar, but a little bit different. Cosine is take the adjacent side over the hypotenuse, and tangent is taking the opposite side and dividing by the adjacent side. Now, each one of these first 3, sine, cosine, and tangent, have what we call their reciprocal function. Remember, a reciprocal means if we took a fraction, 3/4, its reciprocal would be flip it upside down, 4/3. That's what a reciprocal is. And if you look, cosecant is the reciprocal function for sine, meaning sine is opposite over hypotenuse. So cosecant is hypotenuse over opposite. It's just the upside down, the reciprocal. Secant, SEC, is the reciprocal of cosine, and cotangent is the reciprocal of tangent. And how do you spell those? Secant, cosecant, cotangent. So we have our 6 major trigonometric functions. We start with sine, cosine, tangent, and then we flip those 3 over, and that gives us cosecant, secant, and cotangent. One thing I like to point out, because some people get confused, do I put sine with secant or do I put sine with cosecant? How do I know what goes together? Notice that each pair has a co in it. So sine goes with cosecant, cosine goes with secant, and tangent goes with cotangent. That one's probably the easiest to remember. All right. Our next little trick is that we need a mnemonic to help us remember. It's kind of hard to remember these, y'all. Sine, was that adjacent over opposite? Was it opposite over adjacent? What is sine? So there's a little mnemonic that we can use to help us remember what the three main ones are, and then we just flip them upside down for the reciprocal functions. So the mnemonic that we are going to use is called SOHCAHTOA. That's what we see here. So, SOH means sine is the opposite over the hypotenuse side. SOH. Sine is opposite over hypotenuse. Ka means cosine is adjacent over hypotenuse. That's what ka or ka means. And then toa is our third one, and that tells us tangent is opposite over adjacent. So, ka, toa. That's how we remember how to do these problems. All right, let's do a couple of these, and I think you'll get the hang of what we're trying to do here. So, first of all, notice that we have a different triangle here, and we have two different Greek letters. This is Greek letter alpha, and this is Greek letter theta. And our problem is telling us to find the 6 trigonometric functions for angle alpha. So we're focusing on this angle right here. Opposite of the right angle, this is our hypotenuse. And what are the two sides that make up angle alpha? Well, the hypotenuse and this side over here that has the 4 on it. So because the side here is touching the alpha, this one is our adjacent side to alpha. And the one that is opposite is the one with the 3 on it. So let's see if we can come up with what are the 6 trigonometric functions for alpha. So the way we do this is we write sine of alpha. And then what is sine? So opposite over hypotenuse. Well, the opposite side is a 3 and the hypotenuse length is a 5. So the sine of alpha is 3/5. Cosine of alpha. So ca, C-A-H. Cosine is adjacent, which is a 4, over hypotenuse, which is a 5. Toa. So tangent of alpha is opposite over adjacent. Toa. 3/4. That is how you find the first of the 6 trigonometric functions. Then we need to find secant, cosecant, cotangent. And I'm going to remember every pair has a co. So cosine isn't going to go with cosecant. It's going to go with secant. Sine is going to go with cosecant. And tangent, that one's a little bit easier, goes with cotangent. Now, how do I get these? Well, these are the reciprocals of sine, cosine, and tangent. So all I have to do is think that cosecant is going to be hypotenuse over opposite. Secant is going to be hypotenuse over adjacent. And cotangent is going to be adjacent over opposite, or the reciprocal of those functions. And we have just figured out the 6 trigonometric functions of our angle